Okay, so we're going to go a little bit deeper in depth with slope and my y equals mx plus b formula here. So with my equation, the m is always my slope. It's also known as my constant rate of change. So you'll kind of see it both ways. The b is sometimes known as the initial phi. It's also known as the y-intercept. So the y-intercept is where the line crosses the y-axis. All right, so let's first just talk about slope for a second. On our graph here, I have my ordered pairs, I have my graph, I can see the line. So what I'm going to do to find slope from looking at a graph, you have a couple of options. You can see what the change in y is and the change in x, because that's how I find slope. Or you can take two ordered pairs and find your constant rate of change that way. So let's do it both ways. So I have an ordered pair here. I'm going to connect it to the other ordered pair here. So what is my change in y? How much did it go up? So it looks like it went up 1, 2. So my change in y is 2. Now let's see what my change in x here. How far did it go over? 1, 2, 3. So the change between these 2 points, it went over 3. So my change in x is 3. So for my slope, I always do change in y over change in x. So I have 2 over 3. Again, another way to do this, I'll just kind of do this over here off to the side, is I can make a table with those ordered pairs. So for example, I could have 0, 1, and -3, -1, and find my constant rate of change this way. So to do this, find my change in y. It went down 2. This one went down 3. So I have -2 over -3. So negative and negative divided by negative is a positive, so that's 2/3. So whether I do it in a table to find my constant rate of change, or I do my change in y over my change in x on my graph, I'm still going to find my slope or my constant rate of change. Okay, so let's look at it in a table again. I'm going to, again, find my change in y over my change in x. So I'm counting by 1, 1, 5, 5, and 5. Change in y over change in x, 1 over 5. So I have 1/5 for my slope, or in other words, my constant rate of change. Now, when I have 2 points, I'm going to typically just make a table to do this. So I'm going to set up my table, my x and y, similar to how I did this over here. And I'm just going to plug them in. So 3, 0, 6, 2. Change in y is +2. Change in x is 3. Change in y over change in x, 2 over 3. When I have a situation, I'm going to be looking for that per something, each one, the rate that it's going to be changing at depending upon what's going on. So on this one, Pizza Hut charges $7 per pizza. There's my variable because I don't know how many pizzas they got, plus a delivery charge of $3. So right now, all I'm looking for is the constant rate of change. How much is it changing each time? Well, it's changing by the amount of pizzas that they buy. So for my rate of change is 7. A lot of times you'll see it when we start writing the equation, we put it next to the x. But in this case, my constant rate of change is 7. Now let's look at y-intercept. So we're going to do that for the exact same graph, table, points, and situations that we had up here. But now we're going to be focusing on something different. Here on the top part, we found the slope. We found the constant rate of change. Now we're going to be looking for the y-intercept, or in other words, where does the line cross the y-axis? So on a graph, it's pretty easy to tell. I just see here's my y-axis. Where does the line cross it? It crosses it right there at 1. So for here, I'm going to start at a positive 1. With my table, I'm going to be looking for when I have an x value of 0, so in other words, I went over nothing, I just went up or down, what is my y value? As soon as I know when my x is 0, like I have here in my table, that y is my y-intercept. Because when I start graphing, I will go over nothing, but then up 2. So that tells me where my line is actually starting. And this is a positive 2, so my y-intercept is plus 2. All right, when I have 2 points, what I like to do again is make a table. So I have 3, 0, 6, 2. So here's my x values and my y values. So right now, I don't have an x value of 0 like I did over here, but I can kind of work my way backwards and find one. So what I'm noticing here, if I go backwards, is I have 2 minus 2 is 0, if I'm working this way. And then let me take 2 away again, so I'm at negative 2 here. Now let's work this way. Minus 3 takes me to 3, minus 3 again takes me to 0. Now in my table, I have my x value of 0, my y value is negative 2, which tells me when I have the x of 0, the y is my y-intercept. I'm going to be starting my initial point at negative 2. Last one, the situation. This per pizza thing, when I had the $7 per pizza, that gave me my constant rate of change. What I'm looking for here is where I'm actually starting. Where is the initial fee? And in this case, it says plus a delivery charge of $3. So it's telling me I need to add $3 to any order that I have before I start even finding out how many pizzas I want. So I know for sure if they're delivering it to me, I'm going to start at $3. So now what we're going to do is we're going to put this all together with our slope and our y-intercept. Okay, so let's first look at this graph. This graph and this graph are the same. So what I'm going to do is just write my equation. My slope was 2/3. My y-intercept was plus 1. So for my equation, y equals, slope comes first, then the x, then the y-intercept, which was a plus 1. Now we're going to do our next one. The slope was 1/5. The y-intercept was a positive 2. Y equals mx plus b, so slope, x plus y-intercept. Okay, then the next one, I had my slope of 2/3, my y-intercept of negative 2, y equals 2/3 x. In this case, instead of plus b, how it has up here y equals mx plus b, sometimes it can be minus. So in this case, I'm actually starting at a negative 2, so my y-intercept is negative 2. And then my last one, I have a slope of 7, y-intercept of plus 3. Y equals 7x plus 3. And you're going to be doing some practicing with slope and y-intercept.